Hi everyone, my name is Girish from STEMcoachingonline.com, where I'll be publishing various high school courses and some AP courses, AP Calculus AB, AP Physics, Algebra 2, etc. sometime this summer. So please take a note of the website STEMcoachingonline.com. You can reach out to us from the contact us page on the website for now if you need any help. All right. With that out of the way, we know that AP Calculus AB exam is approaching soon. So I just wanted to create this short review video for limits. I'll be creating similar videos for derivatives and integrals as well. So let's get started. So we know limits are an important concept. I'm not going to go through a lot of details in this as I do on my course, but we will try to solve and understand some basic rules and principles of limits by using or applying them to some sample questions. Okay, question 1. Let's find the limit of x approaching 2 to x plus 5. What can we do? This is the simplest case. We can just do a direct substitution of 2 here. This will become 4 plus 5 equals to 9. Direct substitution, okay, easiest one. But we cannot use direct substitution everywhere. Let's just call it direct substitution method, right? You cannot use it everywhere, and we'll know very soon how. Let's say if I want to find limit of x approaching 2 of this expression over x minus 2. If I do direct substitution in this case, what do I get? I get 2 square minus 5 times 2 plus 6 over 2 minus 2, which is 4 minus 10 plus 6 over 0 or 0 over 0. This is indeterminate form. So what should we do? Let's try to factorize. Okay. Limit x approaching 2, the numerator can be factored into these and the denominator can stay as is. Now we know that we can cross out these. So this expression essentially became x approaching 2 x minus 3. Now we can apply substitution method, and that gives us 2 minus 3 equals to minus 1. That is your limit. So we use factoring method to solve and then substitute. Okay. Let's try to do another example. In this example, let's say we have limit x approaching 0 square root of x plus 4 minus 2 over x. Again, first thing, try to substitute, and if it works, that's great. But if you substitute here, what we get? We get square root of 4 minus 2 over 0, which is nothing but 2 minus 2 over 0 or 0 over 0. This is indeterminate form. We cannot use it. So what should we do? Normally, when you see an expression like this in the numerator, always multiply both numerator and denominator with its conjugate. Conjugate is nothing but if you see an expression square root of a minus square root of b, conjugate is square root of a plus square root of b, or any number for that matter. Square root of a minus 2, conjugate will be square root of a plus 2. Okay, so let's try to do that. So our expression here will become square root of x plus 4 minus 2 over x. Will multiply both numerator and denominator by the numerator's conjugate, which is square root of x plus 4 plus 2 over square root of x plus 4 plus 2. Okay, now this is a minus b, this is a minus b, this is a plus b, so this is a square minus b square, x plus 4 square minus b square, and the bottom stays as is, which will give us x plus 4 minus 4, right, over x square root of x plus 4 plus 2. Let's simplify this, and then we will get limit of x approaching 0, x over x square root of x plus 4 plus 2 X and X can cross out, and we get limit x approaching 0, 1 over x plus 4 square root plus 2. Now we can substitute. Okay, so substitute 0 for x. So we get 1 over 0 plus 4 square root plus 2, which is nothing but 1 over 2 plus 2 equals to 1 over 4. So we used rationalizing the numerator technique in this case to solve this question. Okay, let's take a look at another type of question, trigonometric one. Let's see. If I have x approaching 0, sine 3x over x. For all of these questions, guys, please pause this video, try to solve it, and then see my solution. That would be very helpful. Okay, I'm trying to go as fast as possible because it's just a review packet, 10 separate different kind of questions, so that it gives you some quick review notes. So to solve such questions, what do? Now we know this identity. When x is approaching 0, sine of ax, a is any constant, over ax is 1. To solve this, we have to transform this into this form somehow. Okay, so what are we missing here? We have 3x, bottom has x, so bottom should have 3x, which is very easy to do. We can just do sine 3x over x, multiply both the numerator and denominator by 3. Okay, so now we will get, if you look at this expression, right, we have sine 3x over 3x. So we can get 3 out of the entire expression. We get limit x approaching 0, sine 3x over 3x, and now from this one we know that this is nothing but 1, so 3 times 1, which is 3. Okay, let's take a look at it. Another question. In this question, we'll try to do x is approaching infinity, 3x square plus 2x plus 5 over 2x square minus x plus 7. What should we do? So the basic principle is take the coefficient of the highest power of x. In this case, this is the coefficient of the highest power of x, and this is the coefficient of highest power of x. Okay, just take these in numerator and denominator and leave everything else. So the answer will become 3 over 2. I just want to give a little bit more. So why do we do this? So what do we do is, and if you already know this, you can move on, but just to make it clear, why do we take coefficients of the highest power? What we will do here is we will divide both numerator and denominator, right? 2x square minus x plus 7. We'll divide them both by x square. We can do that, right? So the expression will become 3 plus 2 over x plus 5 over x square, right? And this will become 2 minus 1 over x plus 7 over x square. Now x is tending to infinity, right? As x is approaching infinity, all the expressions with x in the denominator would tend to be 0, correct? So this will be nothing but all these expressions, this, and this, right? All these 4 expressions, they will all become 0 as x is a very high number approaching infinity. So we can just say 3 over 2 because those other ones are zeros. Okay, so that's the basic concept behind why we take the highest coefficient of the highest degree of polynomial. Okay, how about piecewise function? Let's say if I have a function defined like this, and I'm pretty sure you all know piecewise function. Piecewise function is a function where it has 2 different rules to calculate the function, based on the variable. So x is greater than or equal to 1. So it says if x is less than 1, x equal to x plus 2. And if it's greater than or equal to 1, it is 4x, right? So we want to find limit x is approaching 1 minus. What does 1 minus mean? 1 minus means, let's say, I'm just going to make something random, okay? This is our graph, and this is x1, 2, whatever. So it says that when limit of x is approaching 1 from the left side, which means x is here, right? So limit of x is approaching from the left side on the graph. This is what it means. Similarly, if I have limit x approaching 1 plus, that means x is approaching 1, which is x is 1 here, but the limit of x is approaching 1 from the right side. That's what it means, okay? And I explained it in the course for the AP Calculus AP. Okay, so let's go back to our question. We want to find limit of this expression when x is approaching 1 from left, and limit of this expression when x is approaching from right, okay? So what do? So let's say, and we call it left hand limit because we are coming from the left hand side, right? Left hand limit. So limit x is approaching 1 minus fx. Now in this case, which one should we take for this? When we are approaching 1 from the left side, which means x is less than 0, it gets very close but never 1, right? So x is less than 1, sorry, I said 0. So when it's approaching from the left side, we will use this expression, okay, which is limit x approaching 1 from negative side, x plus 2, and we can do direct substitution. Don't substitute 1 minus 1. This is x approaching 1 from the left hand side. So this will be 1 plus 2 equals to 3. Now we find right hand limit. Right hand limit will be limit of x approaching 1 from the positive side, and positive side means it's coming from positive side this way. And which expression can we use here? We can use 4x. Substitute it and you'll get 4. Now one more little bit piece of advice. When the left hand limit or left side limit is not equal to right side limit, right? What do we have? The limit, overall limit, does not exist. Do DNE. So that's a function which will have a does not exist limit, overall limit. Okay, so we found left side limit in the piecewise function using correct expression, right side limit using correct expression. Compare these two, they are not same, so the overall limit does not exist. Okay, let's go to the next question. Try to find a squeeze theorem. Okay, this is a question which will find limit of x approaching 0, x square cosine of 1 over x. Okay, how do we find this? Again, pause the video, try to find it, then come back to the solution. Okay, can we write this expression differently? Maybe. Let's see. For any given cosine value, cosine of y is always less than equal to 1, and negative 1 is less than equal to this. Doesn't matter what the value inside this here, right? Now, with that information in place, can we rewrite our expression? We can just say this expression can be rewritten as negative 1 value of the cosine. So it will be negative x square is less than equals to x square cosine of 1 over x, which is less than equals to x square, and limit is x is approaching 0, right? Now when x approaches 0, negative x square is 0. When x approaches 0, positive x square is also 0. So by the squeeze theorem, the limit is 0. Okay, let's do another question. Infinite limit. So if I ask you a question, limit x approaching 3 from the right side, 1 over x plus 3, what is the value of this? Sorry, well, x plus 3 is easier, you can just do substitution. It should be x minus 3, right? So if I do substitution, I don't have any numerator or anything. In this case, it will be plain simple substitution. I get 1 over 0. It's not 0 over 0. So 1 over 0 is still okay. So we'll get positive infinity. Okay. Let's try to do another question. Let's say if I ask you a question, x approaching infinity, we have to find x square plus 5x minus x. Okay. The very first gut feeling that I get is like, hey, put the infinity here, so it will be infinity minus infinity, which is what we don't know, right? Okay, so what do we do? Okay, we'll try to use the conjugate formula, because this expression is nothing but this divided by 1, right? Okay, let's try to apply the conjugate way to solve this. Let's see. So what is the conjugate of this x square plus 5x minus x? Okay, let me just write it again first. So I have a limit of x approaching infinity, square root of x square plus 5x minus x over 1, and I'm going to multiply this with the conjugate of this expression, x square plus 5x plus x over x square plus 5x plus x. Okay, let's multiply this. The top expression will become a square minus b square, so that's nothing but x square plus 5x minus x square, and the bottom stays as is, x plus square root of x square plus 5x. Keep simplifying it, this and this will cross out, so I have 5x over x plus, okay. We have x in all the terms, so what we can do is we can divide everything by x. So I'm going to divide everything, top section as well as the bottom section, by x. This will give me 5 over x plus, if I do square root of x square plus 5x, and if I divide the whole thing by x, inside the square it will become x square, right? So just for simplicity, it will be 5 over 1 plus square root of 1 plus 5 over x. Okay, now this is easy. If I put infinity, now we will get this expression will become 0, because infinity is a very large value. 5 over anything very, very large will become 0. So what we get is 1 plus 1, which is nothing but 5 over 2. And that is our answer. So this is a solving radicals at infinity kind of a question. Okay. And one last question in this video, quick review video before the AP Calculus AP exam from stemcoachingonline.com. We will do a question where we'll combine multiple techniques. Let's say we'll find a limit of this expression as x approaches 1. What is the expression? Square root of x minus 1 over x square minus 1. Okay, we can already see that we cannot really use substitution, because it will be 1 minus 1 over 1 minus 1, 0 over 0. Can we do factoring? Well, if it was x plus x minus 1, we could have done factoring. But this is square root of x minus 1, so we cannot really do factoring. Okay, conjugate to rescue. Okay, so let's see. What we'll do is we'll multiply the numerator. I can actually simplify it also. it doesn't matter. But what we'll do again, we'll multiply the numerator and denominator both by the numerator's conjugate, okay, which will give me limit x approaching 1. We get x minus 1, so x is a square minus b square, x minus 1 over x minus 1 x plus 1 square root of x plus 1. Now this and this can cross out, right? So we got limit x approaching 1 1 over x plus 1 square root of x plus 1. Okay, now we can do substitution, which will give us 1 over 1 plus 1 square root of x plus 1. Sorry, I can just say square root of 1 plus 1 because we're substituting it now. 1 over 2 times 2, which is nothing but 1 over 4. And that is your answer. So I wanted to make this quick video for reviewing limits question for AP Calculus AB exam, which is coming up very soon. Please sign up at stemcoachingonline.com. Our website is live. Courses will be live sometime this summer. So if you know someone who is looking to do AP Calculus or high school math or physics next year, please spread the word, let them know about our site, and hopefully they sign up. Thank you so much. I'll be creating another video about derivatives and integral quick review videos and posting them very soon. So please sign up, subscribe to my channel as well, and I will see you in the next video. Thank you so much.